stone bricks gain ground as low-carbon build option. As scrutiny intensifies around embodied carbon in construction, attention is shifting away from marginal efficiency gains toward more fundamental material changes. Eco Outdoor's latest stone brick range sits within that shift, reframing natural stone as a viable lower carbon alternative to conventional materials like concrete and fired clay. The built environment currently contributes close to 40% of global carbon emissions, with a significant portion tied to the production phase. High-temperature processes used in traditional brickmaking and cement production remain major emissions drivers. Against this, materials that reduce reliance on energy-intensive manufacturing are gaining traction across the value chain. Rethinking production and material use, Eco Outdoor's model focuses on simplifying production. Instead of firing bricks in kilns, stone units are cut directly from quarried material, removing one of the most carbon-intensive stages of conventional brick manufacturing. The company reports emissions reductions of more than 50% across excavation and production compared to standard alternatives. Equally relevant is how raw material variability is handled. Quarrying typically produces inconsistencies in tone and composition, with large portions often treated as waste. In this case, those variations are incorporated into the final product, effectively converting surplus material into usable building units at the extraction stage. This approach extends into broader resource efficiency. Offcuts are redirected into secondary applications such as smaller construction elements, landscaping, or road base. Residual aggregates, particularly calcium-rich material, may also play a role in carbon absorption when used in specific environmental conditions, including marine-based applications. Performance, design, and adoption barriers. Material selection decisions rarely hinge on carbon alone. Durability, resilience, and life cycle cost remain central, particularly in regions exposed to fire risk or coastal conditions. Stone's density supports thermal stability, while its resistance to weathering can reduce maintenance cycles and extend asset lifespan. From a design perspective, the product aims to balance consistency with the natural variation expected of stone. This allows it to align with contemporary architectural demands while maintaining a distinct material identity. Early use cases indicate growing interest from designers who are weighing both environmental impact and long-term performance in material specifications. However, scaling alternatives in construction is rarely straightforward. Cost alignment with established materials, supply chain consistency, and industry familiarity all influence uptake. Eco Outdoor positions its stone bricks as globally accessible and commercially viable, though broader adoption will depend on how well these claims hold under large-scale project conditions. What's emerging is a more layered view of sustainability in the built environment. Materials are increasingly assessed across their full life cycle, from extraction through to reuse, rather than at a single production stage. For developers and contractors, this adds complexity, requiring trade-offs between carbon reduction, cost, and performance certainty. Stone, traditionally valued for its longevity and visual appeal, is now being repositioned within that equation. Whether it can move beyond niche applications will depend less on aesthetics and more on its ability to compete operationally with entrenched materials.